Welcome. In this lesson, we'll open up the black box of large language models just enough for a product manager to make good decisions. We'll cover 3 core ideas: tokens, context windows, and how text is actually generated, and then you'll build a one-page explainer to demystify LLMs for your non-technical teammates. You don't need to be an ML engineer, but you do need a working mental model. Nearly every product decision around AI features, how much it costs, how fast it feels, how reliable it is, comes back to a handful of mechanics. Knowing them keeps you from overpromising in a roadmap and helps you translate engineering reality to the business. First, tokens. Models don't see words or letters, they see tokens, which are chunks of text averaging about 4 characters. Common words are usually a single token, while rare words in code break into several pieces. This matters because you're billed per token on both the input and the output, and because the model produces 1 token at a time, longer answers literally take longer to generate. Next, the context window. This is the model's working memory, the maximum number of tokens it can hold at once, counting both your prompt and its response. Anything that doesn't fit is simply invisible. Critically, the model has no memory between separate calls. When a chatbot seems to remember your conversation, the app is quietly resending the history every turn until it no longer fits. The context limit shapes what's feasible. You can't just paste a 100-page document and expect magic. You need techniques like chunking, summarization, or retrieval-augmented generation, where you fetch only the relevant passages. Bigger windows exist, but they cost more and can be slower, so the goal is relevant context, not maximum context. Now the heart of it: how text is generated. The model takes your tokens and predicts a probability distribution over the next token, picks one, appends it, and repeats. That's the entire loop. It's a very sophisticated autocomplete, not a database lookup. Because it's predicting what's statistically likely rather than retrieving truth, it can produce confident, plausible-sounding errors we call hallucinations. And because it's probabilistic, the same prompt may yield different answers. You can tune that generation. Temperature controls randomness, near zero gives focused, repeatable output, ideal for extraction or classification, while higher values give creativity and variety, useful for brainstorming or copywriting. Parameters like top P and top K similarly narrow which candidate tokens the model considers. As a PM, you should match these settings to the task rather than leaving them at default. Let's tie it together. Tokens trade cost and latency against richness. The context window trades coverage against cost and speed. Temperature trades consistency against creativity. And the prediction mechanism trades flexibility against hallucination risk, which is why high-stakes features need evaluations, guardrails, and sometimes human review. Each mechanic maps to a lever you control. Your task is to write a one-page explainer for non-technical teammates. Cover 4 things: what a token is and why it drives cost, what the context window is and why the model forgets, the fact that it predicts text and can be confidently wrong, and 3 concrete implications for your product. Use one plain analogy per concept and keep it skimmable. Teaching it is the best test of whether you understand it.